Hello again, everybody. Hello, welcome to another video. Hope the video finds you well. This is Raspberry Pi for the older generation. Great to have you back. I want to ask you a question. Have you ever had to measure a large area? For instance, you're having new flooring put down or a new carpet or a bathroom fitted or kitchen, anything. You want your garden landscaped. You have to get out one of them retractable tape measures. Now them retractable tape measures are only majority about 2 meters long, I suppose. 2 meters. And you come to measure and it's all trying to hold it against the wall and it's all not going very well. And you get to the end, you have to mark it, then you have to do the rest of it. Okay, until you get the full measurement, then you have to add it all together. Well, there is a tool out there that does this automatically. You put it against one wall, press a button, it measures to the next wall and it gives you the reading. I believe they work online. I'm not quite sure, never had one. But what we're going to do, we're going to use this. Okay. All right, we're going to use a sonar to achieve the same thing. We're going to measure distance with this. This is the Hc-sr04. All right. Okay, 04. Sorry about that. I've got a message come up on my PC. Right. Okay, let's just have a look at this. Let's just have a look at this. It's got 4 pins. All right, it's got 4 pins. Can you see that? And from the left, it's 5 volts. It's then, I believe it's trig, echo, and ground. All right. Trig. What trig does? Sends out the signal. Echo receives the signal. Okay. Right. Let's have. Should we build a circuit? Let's look at the schematic. Make sure I've got the schematic up. Just checking. Yeah. Okay. Let's build this. Quite a simple little circuit. What I'm going to do this the other way round. All right. So I'm going to put this here. Right. But I'm going to put the cables to the rear. Because I do not want them interfering with the sensor. So the first one I'm going to do, make sure we get it in the right row. There. And there. Yep. So the 5 volts, all right, the 5 volts goes to 5 volts. Oh, it's come out. Bear with me. I want to make sure I get it in the correct hole. Yeah, 5 volts goes to 5 volts. All right, 5 volts goes to 5 volts. Right, and what's the colour for the trig? Yellow. The trigger pin, which is the next one in the row, goes to pin 7. All right, blue. I'm going to use blue. Echo pin, which is the next one along, goes to number 6 on our Arduino. All right, and then finally we have ground. Right, it can go to any ground. I'm just going to take it to the one here. All right, so that is the circuit. All right, that is the circuit. All right, should we do the code? Shall we do the code? Right, let's do the code. Go to here. Okay, open up your Arduino or your IDE, Integrated Development Environment, and start a new sketch. The way we start a new sketch, go File, New Sketch. All right, I've already got one open. And it'll open a new sketch for you. All right. If you haven't got your board already attached, you can confirm that by here. Do your drop down menu. And there you go. If it's not connected, then you select other board and select the board of your choice. The board that you've got. All right. Shall we get on with the the code. Let's do our variables first. So int, what we're going to call it is, I'm going to call mine trigger, and equals pin 7, semicolon. Don't forget your semicolons. Int, space, echo. All right, I'm going to call mine echo, and that equals, we put that on pin 6, semicolons, enter. Always like to leave a space between the codes. All right, so that's our trigger and echo done. All right, so echo is now pin 6, trigger is now pin 7. All right, so we put trigger and echo instead of, what if you want to change the numbers of our pins. Our next one is called long space time. All right, that equals 0, semicolon. All right, value time. Time between the transmission and the returning of the sound wave. All right, so we now refer to long time. And another one is long dist, for distance. That equals 0, semicolon. This calculates the distance. It will trigger with 0 instead of int. All right. We are using long for this value to save a bigger number. All right. So because we're going to, that's all of our variables. That's all of our variables, 4 variables. All right, let's go to the void loop. This starts our void loop. This ends our void loop. Now, because we're going to be using our serial port, so we need to do, let me just do this. Okay, might be putting you off. All right, because I have practiced this. So we're going to set up. Okay, serial dot begin. Let me just check that. Serial dot begin. Yep. Brackets on, and we're going to use the baud rate. That's a communication of the speed between the serial monitor and the Arduino. All right. And we're going to put that on 9600. This is the normal baud rate that we use for the Arduino. You can change it, you can make it faster, you can make it slower, but that's up to you. All right. Now we've got to do our pin modes. All right. Brackets on, trigger, comma, and that's an output. Of course it is, because that's sending the signal out. Okay, semicolon, enter. And I spelled trigger wrong. All right, our next pin mode. Brackets on, and that's echo, comma, and that's an input. Okay, because it's receiving it back from trig. All right. Okay, good. So that's all of our setup command done. Between there and this turns off, this ends the setup. All right, things we only want once. Just to remind you, let's get a bit of space. Right. Void loop. This starts our void loop. This finishes our void loop. All right. Now the first thing we're going to do is a digital write. Brackets on. Wouldn't be bad if I could spell right. Brackets on. Changes colour. Everybody's happy. Trigger. Comma. Low. Capitals. Come outside the brackets. Semicolons. Okay. Low voltage on the trigger. Okay. We want to start with a clear signal. So in the loop, everything's clear. We want a delay. Brackets on 50 milliseconds. Come outside the brackets. Semicolons. So that gives us 5 milliseconds delay. Next, we want another digital write. Brackets on. This time, trigger high, comma, high, all capitals. Come outside the brackets, semicolons. Right. This now starts to create the sound wave. We want the sound wave to be sent out, so we put a delay, brackets on, for 10 milliseconds, semicolon. All right. And then a digital write. Okay, brackets on, trigger, comma, load. All right, I've just seen that. That's a comma. All right, low, semicolons. All right, so that stops the sound wave. So it's gone out, set the sound wave, 10 milliseconds. Bang, it's gone out. All right. Now what we need to do is to collect that information. We need to collect that ping. All right. So it's time space equals, and this command is PULSEIN, pulse in. Brackets on, echo, comma, I. All right. Come outside, semicolons. Pulse in. The Arduino board measures the time between sending and receiving the sound wave. All right. So that's our time. Now we've got to calculate the distance now. So DIST equals, brackets on, time. Okay, time divided by 2. Come outside the brackets. Now what that's doing, the pulse is going out. It's hitting an object and coming back. Say that object is a meter away, but the pulse is taking 2 meters or 2 seconds. Right, so it's giving us double the distance there and back. So what we have to do is divide it by 2. All right. And then it's space, it's a / and it's 29.1. That's the centimeters. Okay. So the sound needs 29.1 seconds for 1 centimeter. And then the timing gets divided into 2, as I said. All right. Does that make sense? Hopefully it does. If it doesn't, please comment below and I'll try and excuse me, I'll try and explain it further. Now we've got an if statement. All right, if and then followed by an else. Brackets on, distance. Okay, space greater than or equal to space 500 space line. All right, distance is less than or equal to 0. Okay, come outside. All right, if the distance gets over 500 centimeters or under the 0 centimeters, the measurement is no longer accurate. Okay, so all we have to do is come down here, curly brackets, space, because I like to have it all nice and neat. Serial dot print ln, because you want print ln, we want it in line. We don't want it going right the way across. If you just put the print, it'll just carry on along a single line. If you put the print LN, which means line, it means it goes line after line after line. All right? Brackets on. Quotes. Oh, got that right. No measurement. I'll put that in. All right? No measurement. That's going to say outside them boundaries, there's going to be a message in the serial port come up, no measurement. All right? So let's go down. Curly brackets turns off the if command. All right? The print line. Now we have the else. All right? Space, curly brackets, enter. Sorry, else, enter, curly brackets, enter. Serial print. Sorry, serial dot print. Serial dot print. Just check this. Yeah, brackets on, makes it a command. Dist. So that will then, if it's within them parameters or outside them parameters, then it will print the distance. Come outside the curly brackets. That's the end of the else command. No, it's not. We still got one command. Sorry about that. Serial print line. Dot print line. Brackets on, and we want it in centimeters. So quotes on, centimeters. Right, quotes off. Semicolon. Enter. Right, now we come out the else command. All right. Let me just tidy things up a little bit. My OCD. So turns on the else, turns off the else. All right. And finally, you want a delay of 1 second. Come outside, semicolons. Cause a short break between measurements. All right, you can make that 2 seconds, 3 seconds, whatever you want. Right. I'm hoping everything's hunky-dory. Remember, no semicolon after the if command. Distance, seen it. Just make sure. Yep, semicolon. Schoolboy error. Check in. Just checking. Right. Shall we verify it? Let's see if we got any issues. Hopefully not. Hopefully not. It might take a little while to compile. Pulse. Let me check this. Time equals pulse in. Echo brackets high. Serial print line. Where's that? Centimeter. Let's check this. Okay. Serial print line not greater than. Let's try again. Okay. Hopefully no more mistakes. Well, we got down to here, so hopefully the delay's okay. delay is okay. If you can see this. Nope, we still got time. It's capital I. Capital I. Pulse in. Yep, it's capital I. Let's verify it again. Sorry about this, guys. We're all human. We're all human. We'll get there. We'll get there. All right. Let's see. Come on, come on. Fingers crossed. Fingers crossed. Fingers crossed. Yes, okay. Sketch is okay. Let's upload it to the Arduino. Let's upload it. Just closing down my serial monitor because I want to show you guys how to open it. All right. It's uploading. Come on, uploading. Uploading. Done uploading. Okay, we now want to read the measurement. So we go Tools. It's here. Serial monitor. All right, and it's connected. It's connecting. It's connecting, and there we go. And we can see the measurements coming up. What I'm going to do before I show you the overhead, I'm going to put something in front, and you can see it's changing. I'm bringing it closer. Eight centimeters. All right. Now, if I come within 5, no measurement. Okay. And then I'm getting longer, longer, and longer away. And we've got a second in between, 36, 16. Okay. Let's go to the overhead so I can show you. Let's put my hand. It's changing, and I'm coming forward, forward, forward. And there we go. All right. So that's showing you how nothing. Put my hand in front. There we go, 10 centimeters, which is about right. What you can do, you can put a tape measure beside your sonar. So there you go. That's how to measure distance with the Hc-sr04 sonar. All right. Okay, great stuff. Great stuff. Now, no more tape measures, getting in a mess, trying to measure longer distances. All right. I don't know how far this sonar can go. Maybe you guys want to try it out, just see how far that you can go with the sonar. All right. I've never done the maximum distance. All right. So no more retractable tape measures. Great, great. Thanks again, and I'll see you in the next video. Variations on a theme. Bye-bye.